Good morning to one and all. See, today in this live lecture we shall discuss the Laplace transform of a periodic function. Up till we have studied different types of functions whose Laplace transform which we have seen. Now here in this today's lecture we have to calculate the Laplace transform of periodic function. Periodic function means sine function, cosine function. These types of functions are called as a periodic function. Periodic function means, in general, a function which repeats their values after some particular period. After some particular period, such types of functions are called as a periodic function. Suppose sine theta. We know that sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is again -1, and sine 360 is again 0. That means 2 pi is the repeated period of a function. A function which repeats their value after some period, fixed period of a time or fixed period, then that function is called as a periodic function. Okay. Now, next we have to discuss Laplace transformation of some periodic function. Actually, we have seen the Laplace transformation of capital L of f of t is equals to capital F of p is equals to L of small f of t is equals to capital F of p is equals to integral from 0 to infinity minus pt into f of t dt. Okay? मोहित गायकवाड कालचे प्रॉब्लेम सॉल्व केले का रे? प्रणति कदम, प्रणाली पाटील, भाग्यश्री, शिल्पा पांचाळ होमवर्कला दिलेले प्रॉब्लेम सॉल्व केलात का? Have you solved all the problems which we have given in the homework? If you have any doubt belonging to the homework problem, then you can ask me. Okay? Now these are the some typical functions whose Laplace transformation is given. Okay? Now, 1 minute. Okay, these are the standard functions. Now this is the important theorem, theorem number 10. Laplace transform of a periodic function. Laplace transform of periodic function. The statement of this theorem is, if f is a piecewise continuous on t greater than 0 and is of exponential order, which satisfies the exponential order condition. This is for differentiation and integration. This condition is for essential condition for differentiation and integration. Exponential order e raised to c naught t, and f is the periodic with a period capital T. Then prove that Laplace transform of f of x is equal, f of t is equals to 1 upon 1 minus e raised to minus p into capital T into integral from 0 to capital T e raised to minus pt into capital F of t dt. Here in this case, capital F of t is the capital F is the Laplace transformation of the small f. Okay. Now we have to prove this result. Actually, according to the definition of the Laplace transformation, we know that what we have known. Actually, Laplace transformation, definition of the Laplace transformation. See this. L of f of t is equals to L of f of t is equals to integral from 0 to infinity e raised to minus pt into f of t dt. Okay. Now, integral from 0 to infinity e raised to minus pt into f of t dt. we know that suppose from 0 to infinity, t is the time period. T is the time period for the periodic function. See this. The periodic with the period t, function f of x or f of t is a periodic in t. After t, it is again the same values. So, we have to distribute this integral from a to infinity in the form of a t, because t is a periodic function. After time t, 2t, 3t, the values of a function get repeated and repeated. So, t is a given periodic function, then our aim is to distribute this periodic function into the two parts, 0 to t. By using the properties of the definite integral, we can convert integral from 0 to t. See this. Integral from 0 to t e raised to minus pt f of t dt plus t to infinity e raised to minus pt into f of t dt. Now, in the second integration, we have to use the substitution method. We have to use substitution of a time period in terms of periodic function or periodic time capital T. So, in the second integrations here, put small t, which is equals to u plus capital T. U is another variable which we have to substitute in place of t, and capital T is the periodic function. And in the second integral, we have to substitute only in the second integral. This substitution is for only the second integral. See this. If t is equals to u plus t, capital T, then dt is equals to du. If we substitute the variable in the definite integral, then we have to change its limits also. When the lower limit is t, then if we put lower limit is t, small t is equals to capital T. Small t is equals to capital T. Then this t will be get cancelled. We will get the result u is equals to 0. So we get u is equals to 0. Again, if we put small t is equals to infinity, that is upper limit, in place of substitution, that is in place of here, if we put small t is equals to infinity, then then for u is equals to t minus infinity. Infinity, suppose this is infinity is not a particular value, so we can't use in the equation, but for the general idea I am going to explain you u plus t. So infinity minus u is again infinity, therefore the value of capital T becomes infinity. So we can write, if small t is infinity, then u becomes also infinity. U is also infinity. Say this, u is equals to infinity. That means after changing the variable in the second integral, in terms of u, we have to write the new limits 0 to infinity. U is equals to 0 to u is equals to infinity. Okay. So now this equation will becomes L of f of t, which is equals to integral from 0 to infinity e raised to minus p into t f of t dt. First integral is as it is. We are substituting only second integration. We are going to substitute variable in the second integral, therefore 0 to infinity, new limits of this 0 to infinity. So we have to write new limits here, 0 to infinity e raised to, in place of small t, we have to write u plus capital T, f of u plus capital T du. U plus capital T du. Now, again we have to solve. Keep this first integral as it is. We have to solve only second integral because we have substituted variable in the second integral. Now, integral from 0 to infinity, multiply by p in the bracket, then what will happen? E raised to minus pu into e raised to minus pt f of u plus t dt. That means we will get this result. But in this case, in the second integral, u is a variable of that integral, integrating with respect to u. So e raised to pt is a constant, you can take out of integration. And see this is very important change. If t is here, if t is the period of a periodic function, time period for the periodic function, then we can write f of x plus t, which is equals to f of x. See this, actually we have given f is a periodic with a period t. We have given the period for the function is t. Then this is a very important formula for periodic function. F of x plus t, we can write f of t, or f of nx, f of x plus nt, which is also we can write f of x. So according to this condition, we have written f of u plus t, which is equals to f of u, because t is the period of a function. Now again we have to solve only this second integration. So keep out of this integration e raised to minus pt, this is the constant. So remaining integration is e raised to 0 to infinity e raised to minus pu f of u du. Now change the variable. Here we have changed the variable. Only we have to change the variable in the function. How we can write? We have to write this second integral in terms of t. So replace the variable u as a t. So integral from 0 to infinity e raised to minus, this is not a substituted variable, we are only changing the variables in the integration. So e raised to minus pt f of t dt and e raised to minus pt f of t dt. After changing the variable, in place of u only we have to put t. Therefore this will be the new integral, which is after getting the period of the function. So this first integral is as it is, and second integral becomes e raised to minus pt into integral from 0 to infinity e raised to minus pt f of t dt. Now you know that according to the definition of the Laplace transformation, integral from 0 to infinity e raised to minus pt f of t dt, we can replace this by Laplace transformation of t. So we can write here we have to write Laplace transformation of f of t. This is according to the definition. We can write this as a Laplace transformation of f of t, and keep this e raised to e raised to minus p capital T as it is. So our next equation becomes Laplace transform L of f of t is equals to integral from 0 to capital P e raised to minus pt f of t dt plus e raised to minus p into t into, in place of this we can write Laplace transformation, that is L of f of t. Now transfer this L of f of t on right side. So L of f of t minus L of e raised to minus pt f of t, which is equals to integral from 0 to t e raised to minus pt f of t dt. Is it okay? Now Laplace transformation, Laplace transformation is the linear transformation, so we can write this linear according to the linearity of Laplace transformation. L of f of t minus e raised to minus pt f of t, which is equals to, on the right side, integral from 0 to capital P as it is. Then you can take f of t as a common. So L of f of t into 1 minus e raised to pt, but 1 minus e raised to p into t, these are the constant terms. So we can take out of the Laplace transformation function. So we will get the result L of f of t which is equals into 1 minus e raised to minus pt. This is in the multiplication with the Laplace transformation. So transfer this on the division on right side. So L of f of t is equals to 1 minus e raised to minus pt into integral from 0 to capital T e raised to minus pt f of t dt. This is our result. This is our result. That is a Laplace transformation of the periodic function. If a period is capital T, if a period is capital T, then Laplace transformation we can write in the form of limits of integral 0 to capital T, and multiplier is 1 upon 1 minus e raised to minus p into capital T. This is the multiplier and limits are in this form. So Laplace transformation L of f of t is equals to 1 upon 1 minus e raised to pt into integral from 0 to t e raised to minus pt p into small t f of t dt. Is it okay? याच्यात काय अडचण आहे का रे स्टुडंट्स? इफ यू हैव एनी डाउट देन यू कैन आस्क मी. केशव घाडगे, सईद, शबाज सईद, शबाना घोष, प्रीतम मिसाळ. If you have any doubt, then you can ask me. Okay? Theorem मध्ये काय अडचण असेल तर विचारा. This is very important theorem. But the main idea of this theorem is we have to distribute Laplace transformation, integral of Laplace transformation from 0 to infinity in two parts, 0 to t and t to infinity. This is the main condition, and we have to change this second integral. Here we have to change this second integral. Now next, now our aim is to find out the Laplace transformation of the function which are repeated function. Okay, so that means we have to find out the hereafter in the example we have to find out the examples based on periodic function, Laplace transformation, which are based on the periodic function. Okay, now find the Laplace transform of half wave rectified sinusoidal f of t is equals to sin t. F of t, we have given the function f of t which is equals to sin t in between 0 to pi, and f of t will be 0 in the period pi to 2 pi, in between pi to 2 pi. Okay, where f of t plus 2 pi which is equals to f of t. Here the period of function is periodic function 2 pi. Here lambda is 2 pi, or here capital T is 2 pi. Okay, now we have to solve this problem. Actually, the function f is a periodic with a period t is equals to 2 pi. And according to the theorem, we are L of f of t is equals to 1 upon 1 minus e raised to p into capital T into integral from 0 to capital T e raised to minus pt into f of t dt. Okay, for the period t is equals to 2 pi, that means we have to shift. Here in this case, the period of a function is given capital T is equals to 2 pi. So we have to write on the right side or the integration in place of t is equals to 2 pi. Students, now you tell me, what is the value of cos 0? जो भी बच्चे ऑनलाइन है, हमें वैल्यू बताना है cos 0 की. What is the value of cos 0 and cos 2 pi? Or you can tell me the periodic value of cosine function. चलो ऑनलाइन कौन कौन आहे ते पाहायचं. So now replace this. In place of t, we have to replace 2 pi. Here is t, we have to replace 2 pi. Here is t, we have to replace 2 pi. Because in this problem, we have t is equals to 2 pi. Okay, Manisha Rathod, Patil, Pandit, Shubhangi, Saida, Gauss, Bhagyasri. Okay. Now, due to this replacement of the period capital T is equals to 2 pi, our integration form will be 1 upon 1 minus e raised to minus p into t. In place of p into t, we have written 2 pi. Here is also 2 pi. That we can write as 1 upon 1 minus e raised to 2 pi into p. Integral will be from 0 to 2 pi. Remaining terms are as it is. Okay. So 1 upon 1 minus e raised to 2 pi p into integral from 0 to pi, 0 to pi. Actually, in the problem we have given this, we have defined according to the definition of this function f of t. This function having two different values. From 0 to pi, it has a sin t, and from pi to 2 pi, it has 0. So our aim is to distribute this integral from 0 to 2 pi in the form of a pi, because f of t has different value in between 0 to pi, and it has another value in between 0 to 2 pi. So we have to distribute this integral from 0 to pi and pi to 2 pi. What is the definition? You know that the definite integral formula, integral from a to b f of x dx. Then we can write if a is less than c is less than b. If c is lies in between a and b, then we can write here integral from a to b f of x dx, which will be integral from a to c f of x dx plus integral from c to b f of x dx. This is the property of definite integral which distribute the integration in between s value. If c is in between a and b, then we can distribute this. Okay. So according to this property, we can write we have to distribute it 0 to pi. हे पायच का सिलेक्ट केला रे स्टुडंट? इथं मी पायच का घेतला? पाय बाय 2 ला डिस्ट्रीब्यूट का नाही केला? Now you tell me the answer. I have distributed this integral by the point pi. Why we have not used here pi by 2? Anyone can tell me the answer regarding this? Why we are not used here pi by 2, pi by 2? Okay. So now we know that from pi to 2 pi, the value of f of t is 0. Value of f of t is 0 according to the given condition here. Value of pi to 2 pi, 1 minute. See this. Value of pi to 2 pi, the value in between pi to 2 pi, the value of a function is 0. So we have written 0 to pi, f of t is equals to 0, because from pi to 2 pi it will be 0. So because it gives a 0 to pi, okay, 0 to pi, it has a value, and pi to 2 pi is another value. So pi is the intermediate point. So we have to distribute this in by using a pi. Okay, no problem. And in between 0 to pi, see this, we have given sin t. Replace sin t, f of t is equals to 0, 0 into e raised to minus pt means 0. So second total integral will be 0, and in place of first, f of t is equals to sin t. Now, so keep this value as it is. So Laplace transformation of f of t is equals to 1 upon 1 minus e raised to 2 pi t into integral from 0 to pi e raised to pt into sin t. Okay, this is the Laplace transformation. Now our aim is to solve the integral. आता आपल्याला हे इंटिग्रल सॉल्व करायचे. Integral solve करायचे. Integral from 0 to pi e raised to minus pt into sin t dt. And you know that integral from, already we have expressed the formula, integral of a raised to ax into sin ax dx. Already we have given the formula. According to that formula, we can expand this integral. We can find the integral e raised to minus pt divided by p square plus, suppose this sin ax is the sin bx. 1 minute. Already we have given the formula for this. So by using this formula, we can write, or we can take the integral e raised to minus pt divided by p square plus 1. Here b is 1. Here b is 1. According to this formula, b is 1. A is p. So e raised to minus pt divided by p square plus 1 into minus p into sin t minus cos t over the limit 0 to 2 pi. 0 to pi. If we keep this as it is, when we put the upper limit in place of t, we have to put pi. So e raised to minus pi t. See this, e raised to minus pi t. Now, if we put upper limit in place of t, sin t means sin pi, which goes to 0. Cos t means cos pi, which goes to minus 1. Minus minus plus 1. So it will be 0 plus 1. Now, if we put the lower limit means 0, then what will happen? E raised to minus p into 0 means e raised to 0. E raised to 0 means 1 divided by p square plus 1. So it will be 1. And if we put the lower limit here in the t, so minus p into sin 0. Sin 0 is 0, so it will be 0. And cos 0 is minus 1, then it will be the minus 1. So after putting the upper limits and lower limits, we will get these values. Now, see this e raised to minus pt into p square plus 1, e raised to minus pi p divided by p square minus 1 multiply by 1. And again minus minus plus 1. So minus minus plus 1 upon p square plus 1. Now take the LCM, p square plus 1, p square plus 1. So remaining term is 1 plus e raised to minus pi p divided by p square plus 1. This is the final answer for the Laplace transformation of this periodic function. This periodic function f of t have the value sin t in between 0 to pi, and f of t is equals to 0 in between pi to 2 pi. See this. This is the complete answer for this. Okay. Now we shall move towards the next problem, because see this theorem is a very important, and this problem is also very important regarding this theorem, because see this, because this theorem includes the problem and which goes to the 15 marks for the examination. So you have to solve both theorem and problem. Now second problem, we will move towards this problem. Find the Laplace transformation of the following. F of t is equals to, see this, f of t is equals to integral from 0 to t u square minus u plus e raised to minus u du. Now here f of t is equals to integral from 0 to t u square minus u plus e raised to minus u du. We know that, actually we have seen the theorem. What is the theorem? Laplace transformation of integral from 0 to t f of u du, which can be written as capital F of p divided by p. Here capital F is the Laplace transformation of small f. You must know this, you must remember this. Okay. Now Laplace transformation of this t square minus t plus e raised to minus t, which is equals to 2 factorial divided by p cube minus 1 upon p square plus 1 upon p plus 1. How we get this result? See here, Actually, according to this definition, Laplace transformation of t raised to n is n factorial divided by p raised to n plus 1. N factorial divided by p raised to n plus 1. This is the definition of the Laplace transformation. Laplace transformation of t raised to n. Okay? So, Laplace transformation, say this, we can separately calculate this. Laplace transform of t raised to n is n factorial divided by p raised to n plus 1. Or we can write gamma of n plus 1, whatever may be. So Laplace transformation of t square, which will be 2 factorial divided, if we put n is equals to 2, then we will get 2 factorial divided by p raised to 2 plus 1. Means 2 factorial divided by p raised to 3. So this result goes to here. Similarly, Laplace transformation of t, then second term is t. So Laplace transform of t, here n is 1. So n factorial means 1 factorial is 1 divided by p raised to 1 plus 1 means 2. So we will get this second factor. And Laplace transformation of e raised to minus t, you know that 1 upon p plus 1. So the Laplace transformation is the linear transformation. We can calculate Laplace transformation of t square minus Laplace transformation of t plus Laplace transformation of e raised to minus t, which gives the resultant value. This, consider this value as a capital F of p. Consider this value as a capital F of p. Now see this. According to the theorem, Laplace transformation from 0 to t u square minus u plus e raised to minus u du. We have to convert this in terms of u. Capital F of p divided by p. Keep this p as it is. And capital F of p we have calculated in terms of p, that is 2 factorial divided by p cube minus 1 upon p square plus 1 upon p plus 1. So replace here capital F of p means this. Then we will get multiply by 1 upon p, then we will get the result 2 by p raised to 2 factorial divided by p raised to 4 minus 1 upon p cube plus 1 upon p into p plus 1. Then 2 factorial is again 2 divided by p raised to 4 minus 1 upon p cube plus 1 upon p square plus p. Or keep this as, this is the Laplace transformation of the integral from 0 to t u square minus u plus u raised to minus u e raised to minus u du. Do you understand this? समजलं का रे स्टुडंट? समजते का काय झालं ते? सिंपल प्रॉब्लेम आहे, काही अवघड नाही, सिंपल आहे. Now next we have to move towards the next problem, important problem. That problem is, if Laplace transformation of t raised to minus 1 by 2 is root pi divided by p. Already we have calculated this formula which we have already calculated. If Laplace transformation of t raised to minus 1 by 2 which is equals to root pi by p. बाकीचे आन्सर देत नाहीत रे, विचारलेल्या क्वेश्चनला आन्सर देत नाहीत म्हणजे लेक्चरला अटेंड नसतं का ते? बहुतेक लेक्चर करत नसतात वाटतं, उगं प्रेझेंटी टाकून जातात वाटतं. मी क्वेश्चन ह्याच्यासाठी विचारत असतो की मला पाहायचं असतं कोण कोण आन्सर देत आणि कोण कोण प्रेझेंट आहे ते. मला ह्याच्यावरूनच लक्ष येते तो कोण कम्प्लिटली लेक्चर कम्प्लीट करायला लागलं काय नाही. नाउ find Laplace transformation of 1 plus 2at divided by root t into e raised to at. We have to find out Laplace transformation of this by using a given condition. Laplace transformation of t raised to minus 1 by 2 which is equals to root of pi by p. Okay, now see here, given that Laplace transformation of t raised to minus 1 by 2 which is equals to root of pi divided by p. Now first of all we have to consider this function is f of t. Suppose then Laplace transform of 1 plus 2at divided by root t which is equals to Laplace transform of 1 plus 2at into t raised to minus 1 by 2. This root at we can write t raised to 1 by 2, and in the numerator we can transfer it as a t raised to minus 1 by 2. Now again multiply by t raised to minus 1 by 2, 1, t raised to here. So Laplace transform of t raised to minus 1 by 2 plus 2at into t raised to 1 by 2. You know that Laplace transformation is the linear transformation, so we can write Laplace transform of t raised to minus 1 by 2 plus Laplace transform of 2at into t raised to 1 by 2. But 2a is the constant coefficient, so we can take without Laplace transformation. So Laplace transform of 2at, Laplace transform of t raised to 1 minus 1 by 2 plus 2a as it is Laplace transform of t into t raised to minus 1 by 2. But here, student, here we have to use the formula. Which formula we have to use here? Actually, for the Laplace transform of t raised to n into f of t, then what is the result? Who can tell me, students? What is the result for this? We have to write minus 1 raised to n series minus 1 raised to n dn by dp raised to n into capital F of p, where capital F is the Laplace transformation of small f. This formula which we have to use. So here is a t raised to 1 into f of t is t raised to 1 by 2. So n is 1. Here in this case n is 1. And f of t is t raised to 1 by 2. Its Laplace transform is already we have given root pi plus p. And first order derivative, because n is 1 here, so minus 1 raised to n, in place of n we have to write 1 into the first order derivative. Very good, Pranali Patil. फक्त प्रणाली पाटीलच प्रॉम्प्टली आन्सर देत असते प्रत्येक क्वेश्चनचं. बाकीच्यांचे काय करतात मला हे समजत नाही, कुठं लक्ष असतं. So we have to write this formula. Laplace transform of t raised to minus 1 by 2 is given. What is that? Root pi by p. Keep this as it is. Plus 2a as it is. And now we have to use the standard form theorem. So 2a into minus 1 raised to 1 first order derivative, because n is equals to 1 d by dp of, and Laplace transform of t raised to 1 by 2 is, we have given root of pi plus p. Okay, so 1 minute. Hello sir. मी थोडा ऑनलाइन लेक्चर चालू आहे, मी लावतो नंतर. हो, the pi we have to write t raised to minus 1 by 2 is equals to root pi plus p. Okay, so according to this we can write, 1 minute. This is a simple. Now root pi by p minus 2a into dp by d by dp of pi divided by p bracket raised to 1 by 2. Actually you know that root means we can express this root of pi by p, we can write in the form of index or the power 1 by 2. So pi by p bracket raised to 1 by 2. Again 1 by 2 means root pi. It is the constant quantity, so we can take out of derivative. So 2a root pi into d by dp of 1 upon p raised to 1 by 2. So 2a, keep this first term as it is. There is no any change up to last. We have to solve only the derivative. Our aim is to solve the derivative. Okay. So now 1 upon p raised to 1 by 2. So we can write p raised to 1 upon p. Say this 1 upon p, we can write its power 1 by 2. So we can write p raised to minus 1, its power 1 by 2. So we get p raised to minus 1 by 2. Okay, this is the rule of index. So p raised to minus 1 by 2. Now differentiate this p raised to minus 1 by 2 with respect to p. Power multiple मध्ये घ्या, power 1 न कमी करा, means minus 1 by 2 into p raised to minus 1 by 2 minus 1, means which will be the result as minus 3 by 2. So this minus to this 2 will be get cancelled, minus minus will be plus a root pi into p raised to minus 3 by 2. Then p raised to minus 3 by 2 we can write in the denominator p raised to plus 3 by 2. P raised to 3 by 2 we can write it as a p root p. So we can write as a p root p. So the final answer will be root pi by p plus a divided by p into root of pi by p. We can take a common root pi by p also here. Then which are the remaining term in the bracket, student? Now you tell me. So 1 plus a upon p. You can take. Consider this function as a Laplace transformation for this function as a capital F of p. Laplace transformation of this capital F of p. Now we have to take the Laplace transform of this function into e raised to t, e raised to at. That means we have to use the first shifting property here. And what is that, student? Tell me. Laplace transform of e raised to at into f of t. What is the formula for this? First shifting property. Chala re sanga first. We have to use first shifting property because already we have calculated the Laplace transformation of this function. Into we have to calculate the Laplace transform of e raised to at into f of t. So we have to use the first shifting property, that is f of capital F of p minus a, where capital F is the capital F is the Laplace transform of small f. So according to this we have to use the first. Now by the first shifting property, Laplace transform of e raised to at into 1 plus 2at divided by t. t नहीं है, हाँ माझ्या मतानुसार 1 by root t है. Okay, so I have written by mistake here t. So root t e raised to at into 1 plus 2at divided by root t, which is equals to capital F of p minus a. So we can write in place of this root of pi minus p minus a plus a divided by p minus a, root of pi minus p minus a. Root of pi minus p minus a is the common term. So remaining term is 1 plus p divided by p minus a. And if you take the LCM of this, LCM kada, p minus a plus a minus a plus a will be get cancelled. So p divided by p minus a. This is the complete Laplace transform of given function. समझलं का रे student? If you have any doubt, then you can ask me. Then again, this is very important problem. See this. ओके, तर हे प्रॉब्लेम पुढचे जे याच्यानंतरचे जे प्रॉब्लेम्स वगैरे आहेत ते आपण दुपारच्या सेकंड सेशन मध्ये घेतो. 6 वाजता परत आपण लेक्चर घेणार आहोत. तर या ठिकाणी इथपर्यंत कुणाला काय अडचण आहे का विचारा. इफ यू हॅव एनी डाऊट then you can ask me. And in the evening lecture again we shall take the lecture on remaining part. Okay, lecture on remaining part. If you have any doubt then you can ask me, students. Actually on the Laplace transformation we have to cover nearly about 60 lectures, 60 minimum 50, because we have to cover the 4 different units and each unit needs nearly about 15 lectures. So we have to cover 60 lecture on the Laplace transformation. Okay. Yes, now we shall stop here. If you have any doubt, then you can write in the chat box. I will explain in the next period. Also, we have to solve some problems based on the periodic function. How to find out the Laplace transformation of periodic function, we shall see in the evening lecture. There is today there is another lecture evening at 6 p.m. Okay. Yes, it is from H.K. Das. Again, we have to use another book, that is Gupta Goyal. There are different number of books regarding this. I am going to combine all these books, and I want to give you a perfect types of solution. Okay. AK-47. Yeah, but yes. These lectures are sufficient for the Laplace transformation. But in addition that, you have to solve previous question paper regarding GATE examination. You have to solve the previous question papers from the GATE examination on the Laplace transformation. But these lectures are sufficient for the GATE examination or any type of examination. Only you have to solve the previous examination question paper for SET, NET, GATE. But this part is sufficient for SET, NET, GATE. But for the addition preparation of examples, you need previous question paper. Okay. Thank you. If you have any doubt, sir, please. Okay, no problem. I will explain in Hindi and English because there are number of students with us. Maximum students are in Marathi, so sometime I am going to tell in Marathi. Okay, no problem. I will explain in the English also. Thank you. Now we shall stop here. Remaining part of this periodic functions example we will see in the later examination, or in the evening lecture or evening seminar. Thank you.